So today we're going to talk about recycling of matter. Most people like this mini unit because you've learned about probably half of it already, and it's pretty easy. So, yay. Okay, so first thing we have is ecosystem recycling. We spent the last couple weeks before Thanksgiving break talking about energy recycling, okay? So energy is crucial to an ecosystem, but the organisms need more than energy to survive, right? I can't just give you ATP and be like, sweet, you can live forever now. You still need water, you still need protein, you still need vitamin C, you need all sorts of things in order to function, right? So for most organisms, more than 95% of your body is made up of only 4 elements. And actually, we've talked about the 6 most common elements way back at the beginning of the year. You guys remember chop-ins? When we talked about chop-ins? Carbon, hydrogen, oxygen, phosphorus, nitrogen, and sulfur. Very good. Okay? So the 4 big ones are CHON, carbon, hydrogen, oxygen, nitrogen, and then the next 2 are phosphorus and sulfur. So there's an abundant supply of these elements on Earth, and they must be in a form that that our living cells can use. Okay? We cannot just absorb carbon dioxide from the air and make carbon molecules for ourselves out of it. That's why we have to eat. Good? All right, so recycling in the biosphere. Energy and matter move through the ecosystem in very different ways. Okay? Energy only moves in one direction. From the sun to the carnivore, or to the top consumer, right? Does the eagle give energy back to the grass? No. Okay? So it's a one-way path.
Unless it goes poops into the soil and supplies fertilizer.
But that's not energy. That's a material. It's not actual ATP. So energy enters the ecosystem in the form of sunlight and exits the ecosystem in the form of heat. Right? We all give off heat by just being a living thing. In fact, that's one of the ways they can determine how long a crime scene victim has been dead, is because your temperature drops at a steady rate after you die. Because you are no longer making heat. That's how I do it. This energy cannot be recycled. It goes sun, plants, animals, back to outer space. Right? We cannot make plants grow using our body heat. That'd be weird. And I feel like we'd all be covered in moss or something. On the other hand, matter is recycled. Okay? Within and between ecosystems. This means that, let's say, you go to In-N-Out and you have a hamburger, right? And you are eating all that delicious protein and fat and everything from your hamburger. Okay? It made all of those proteins that the cow was made up of, all the muscles, came from elements in the grass that the cow ate, right? And all of those elements came from the atmosphere when the plant did photosynthesis. So we can see that the actual atoms are getting recycled through everything. There's only so much carbon on the planet. There's only so much oxygen on the planet. It just gets broken down and reused in different ways. So one day this carbon atom might be part of George Washington's body. The next day it might be part of a sugar molecule. Okay? It just depends on what it gets broken down and reused as.
So the material in my shoes could
Okay, so biogeochemical cycles. Elements and compounds are recycled in biogeochemical cycles. Hold on a second. I'll be right there. So the biogeochemical cycle connects the biological, geological, and chemical aspects of the biosphere. Here we go. So, biogeochemical cycle. Everything biological, meaning all the living things, okay, require geological aspects, right? We have to get calcium somehow in order to make bones, right? You have to have nitrogen in order to make amino acids, in order to make protein. So that's the geological part, and the chemical part is the actual atoms, like calcium and carbon and nitrogen and oxygen that we all require. Okay, so when we say biogeochemical cycle, we're connecting those three aspects together. All right, there are only 4 biogeochemical cycles that we are going to learn before our test.
The water cycle.
The first one is the water cycle. Very good. It is the easiest one because you probably already know most of it. Yay! The carbon cycle, which is also pretty easy since we did photosynthesis and cellular respiration. And that's the basis of the carbon cycle right there. Okay? The nitrogen cycle is really important when we talk about farming and things like that. And last but not least, we are going to learn about the phosphorus cycle, which is of lesser importance, and we're only going to take about a half page of notes on, so that'll probably be your favorite cycle. Water cycle. Everyone knows the water cycle is crucial to life, right? Living cells are 70 to 80% water. You, as a person, are 70 to 80% water. You're just a weird bag of water walking around talking to other weird bags of water. Okay? The importance of water is the fact that it provides an environment in which chemical reactions can occur. Without water, our chemical reactions, such as making ATP or breaking ATP, would not be able to happen. All right, so at any given time, the water on Earth can be found in the following places. Okay, these are the main 4. Oceans, lakes, and rivers, right? So large bodies of water. That's what we all think of. When you're like, where's the water? You're like, beach. Okay?
She says something else.
Nope. Just keeping it entertaining. Second one is stored in the bodies of living organisms. Do you have water in you?
Yes.
Yes, that is why when you die, you start to leak.
You poop.
You leak fluids all over the place. Actually, at first you start to swell up and puff up from all the gases. And then as they condense and you start to deteriorate, you just start draining water everywhere. That's why mummies are always what? They're always very dry, right? Things that mummify the best, either one, are in ice, so it's a solid. You don't have to worry about the water breaking it down that way. Or 2, it's in a desert and it's super dry.
Lovely information.
3, in the atmosphere as clouds and water vapor, right? We all see the clouds and go, oh, look, it looks like it could rain, like it did today. And stored in underground formations such as groundwater, which is what we use to survive, right? So oceans contain about 97% of the water on Earth. Can you drink ocean water for a long period of time and survive?
Yes.
No. No. It will actually make you die faster. You're stranded on a deserted island. Shh. Too expensive to do that. All right. 2% of it, of all the water, is found in glaciers. And it's generally frowned upon for us to take an ice pick, hack up a glacier, and serve it to people as drinking water. Okay? Not good for the environment. And last but not least, 1% of all the water on Earth is available in lakes, rivers, and groundwaters. Only 1% of the water found on the planet is usable drinking water. And that is assuming we haven't polluted the heck out of it yet, right? Do you guys remember hearing about the Dakota access pipeline thing? Everyone was protesting it. It was on the news and in politics for a while. It was a giant oil line that was supposed to be going all the way from Canada all the way down through the U.S. And they were protesting and camping out. And it was a really big, political forum for people because they were afraid that if there was an oil leak, it was going to contaminate all the drinking water for that entire county. Guess what happened last week? Oil spill, and all the drinking water for that county has now been destroyed. Crazy, right? The movement of water between these various reservoirs is known as the water cycle. Okay? There are 4 processes that move water through the water cycle. They are evaporation, precipitation, it's when Mother Earth gets some street cred and makes it rain. 3, transpiration. And last but not least, condensation. All right, steps to the water cycle. In the process of evaporation, water molecules are added to the atmosphere in the form of water vapor, right? It's a hot day. You spill soda out in Tealandia on the blacktop. Eventually, it dries up because the water turns into water vapor and it goes into the air, right? So heat causes water molecules to evaporate from bodies of water and from the bodies of living organisms. So you want to label your paper, sun, here's the lake, and there is evaporation happening from the lake and other things that is causing water to go up into the sky. All right. Transpiration also adds molecules of water to the atmosphere. Transpiration is the loss of water from the leaves of plants. I don't even understand. Oh, there we go. Wait, are you playing yourself?
No. I was going to go first. She said forever. Did you press in?
Because she's trying to take the notes. All right, water enters plants through the roots and travels to the good, and then to the leaves. Excellent, right? And the leaves use water for what awesome process that we learned about? Yes, and it goes full cycle. Okay, so here's our picture. There's a shrub and a tree. The water enters the roots, and it gets evaporated through the leaves in the form of transpiration. Okay? Now, this happens for a specific reason. The leaves contain these little pores called stomata. That's how they take in the carbon dioxide in order to do photosynthesis. But when they open the stomata, guess what comes out? Water.
I'm so smart.
Yes, you are. All right. The water vapor in the atmosphere then condenses to form clouds. And this is known as, anyone? Yes, condensation. So as you can see up in the cloud, we write Water vapor condenses to form clouds, and we call that condensation. Animals also contribute water molecules, okay, to the water cycle, but in a much less significant way. We lose water when we breathe, right? If you ever breathe on a mirror to wipe it off, you know how you can see the condensation on it? When you sweat, because you're out running the turkey trot before Thanksgiving. Or excrete. What does excrete mean? Go to the bathroom. You getting rid of some water? And some other stuff? All right. All right. So water leaves the atmosphere and returns to Earth through the process of precipitation, okay? It can only hold so much water vapor, so once it meets that point, due to the temperature and air pressure, eventually it will rain, snow, sleet, hail, or fog up. Okay, so I've printed this for you on your paper because I'm just so nice like that. You're welcome. However, there is one error. This should say not carbon. That should say water, H2O. So, in your notebook, and I will show you an example, you are going to draw a picture of the water cycle in your notes. And I do not want it to look identical to the water cycle I gave you in your notes. You need to be creative. Okay? And answer the following questions based on page 75 of your textbook. They will help you answer these questions. Okay? There are 9 bullet points. Technically 10 questions, because if you look at the last one, there's 2 questions in one. So I think I was just being mean there. And I'll show you what this is supposed to look like. Should look like this in your notes. Okay, so your lecture notes will be on the left side of your Ian, and the drawing will be on the right side, and then you can answer the questions using page 75 on the bottom half of your paper. All right? Okay, you guys can go ahead and get started.